Welcome. So this video is on some different equations. They're all going to be written in quadratic form. Here's the first one. This is nothing new. We've done this before. Solve by factoring. So in previous lessons, we've talked about completing the square. We've talked about the quadratic formula. But this one we could just go ahead and solve by factoring, just to kind of review a little bit. All right, so what do we do first? Well, we got a 0 on the right-hand side. That's good. The trinomial is in order on the left-hand side. That's good, right? Descending order. So multiply the first number and the last number. I'm going to use grouping, but there's many methods for factoring. So multiply the first number and the last number. That gives us -30. List the products. So that's 1 and 30, 2 and 15, 3 and 10, 5 and 6. And because it's a -30, we want to find the pair that subtracts to be 13. Not adds to be 13, but subtracts. Yeah, that'll be 2 and 15, not 3 and 10. 3 and 10 adds to be 13. So we're going to use 2 and 15, and then insert the signs. The 15 has to be negative, and the 2 must be positive. Also, when you multiply those two numbers, +2 times -15, it equals -30. If you try to use 3 and 10, they would both have to be negative, -3 and -10, and that would equal a +30, so that won't work. All right, so separate the middle term into two terms. So a +2x minus 15x in the middle, and then factor an x from the first pair and a -5 from the second pair. So in both parentheses, we get 3x plus 2. So it does factor 3x plus 2 times x minus 5, and then bring down the equal 0. Now we could set them both equal to 0 and solve each equation. So on the left, subtract 2, then divide by 3. So we get x equals -2/3. And the one on the right, add 5 to both sides, and then you're done. X equals 5. So we have two answers, -2/3 and 5. If I do go too fast through a problem, you could always rewind it. Play it back again. Okay, here's our next problem. This one has fractions. Whenever we have fractions, we find the LCD, multiply each fraction by the LCD to clear the fractions. So one denominator is n, and the other one is n plus 4. We also must consider the restrictions. The restrictions are that we cannot have 0 in the denominator. So in the first fraction, n cannot be equal to 0. And in the second fraction, n cannot equal -4. What happens if we have 0 in the denominator? Right, it's called undefined. Okay, so our LCD, what would our LCD be? It would be n and n plus 4. So multiply each fraction by the LCD n and n plus 4. This way, we could cancel all our denominators. So there has to be an n by itself. That way in the first fraction, the n's will cancel. And in the second fraction, the one in the middle, the n plus 4's will cancel. Okay, on the right, 1 times n plus 4, nothing cancels, so you're just going to have to distribute that n. So distributing the 6, we get 6 times n plus 4 minus 12n equals n squared plus 4n. Okay, distribute the 6. So 6n plus 24 minus 12n equals n squared plus 4n. Okay, now we need to get 0 on one side. So combine like terms first. On the left side, the 6n and negative 12n combine to equal a negative 6n. So now bring the 6n to the right-hand side. So if you add 6n to both sides, that's going to give you a 10n on the right-hand side. And then subtract the 24 on both sides. So we get 0 equals n squared plus 10n minus 24. If you want to, you could put the equal 0 after the 24. It doesn't matter. Okay, factor that. That one's an easy one to see. For 24, because there's no number in front of the n squared. Let's see, there's 4 and 6. No, 4 and 6 does not subtract to be 10. It adds to be 10, so not 4 and 6. Right, how about 12 and 2? Positive 12 and negative 2. So that factors to n plus 12 times n minus 2. I didn't show all the steps there, but feel free to list all your numbers, circle the correct pair. If you want to do it by grouping, you can. All right, so we have two answers, negative 12 and positive 2. All right, this problem is very similar to the last one. Our restrictions, x cannot be 2 and x cannot be 1. LCD, right, the LCD is going to be each factor that's in the denominator, x minus 2 and x minus 1. So we're going to multiply each fraction by the LCD. Now we don't have to distribute first, we're going to cancel first. So I wrote the x minus 2, x minus 1 next to each fraction, even the 1. Right, 1 is a fraction, it's 1 over 1. Okay, now we can cancel. In the first fraction, the x minus 2's cancel. In the middle, nothing cancels. And on the right of the equal sign, the x minus 1's cancel. Okay, so distributing the x on the first fraction, that's x squared minus x. And then we have plus 1, and then FOIL, or multiply the x minus 2 times x minus 1. I did skip little steps there, but it's x squared minus x minus 2x plus 2. And the minus x and minus 2x equals a minus 3x. And on the right, distribute the 8, so that's 8x minus 16. Okay, now the 1 in front of the parentheses in the middle there, that doesn't affect anything. If you distribute that, it's going to be the same thing. So now adding like terms, you get 2x squared minus 4x plus 2. All right, again, we need to get 0 on one side, so subtract 8x to both sides and add 16 to both sides. So you should get 2x squared minus 12x plus 18. Again, take your time and go through all the steps. Now we need a factor out of 2. And then that's a perfect square trinomial. 9 is 3 times 3 and adds up to be 6, so it's going to be x minus 3 times another x minus 3. So now, as far as our solutions go, if you set x minus 3 equal to 0, we get x equals 3. We get it for both sets of parentheses, so x equals 3. The 2 in the front we could ignore because it's just a constant. So our answer is only x equals 3. We could do a check if you want. Normally I don't do a check all the time just because it's a pain. But if you're taking a test, you might want to do it. You want to make sure you get a good score. On homework, it's just easy to look in the back of the book or on the answer sheet. But you should know how to do a check. That way you can check your answers. We all make mistakes. Everybody does. Okay, so plug in 3 everywhere you see an x. So 3 over 3 minus 2 plus 1 equals 8 over 3 minus 1. Simplify the denominators. 3 minus 2 is 1, and 3 minus 1 is 2. So 3 over 1 is 3, so 3 plus 1 is 4, and on the right-hand side, 8 over 2 is also 4. So this answer does check. X equals 3 is the correct answer. And also, we should note that it doesn't meet one of our restrictions. The restrictions was x cannot equal 1 and x cannot equal 2. So that would mean if we would have got x equals 2 for an answer, it's a restriction, so we cannot have x equals 2. We would have to cross it out and put no solution if that's the only answer we had. Likewise, if we would have got x equals 1, we would have to cross it out and say no solution. But x equals 3, that one's fine. Okay, this one's a little bit different, although we have factored problems like this in the past. It's still factorable because the degree of the middle term is half the degree of the first term. Okay, so we could still factor it. 84, quite a long list, right? 1 and 84, 2 and 42, 3 and 8, 4 and 21, 6 and 14, and 7 and 12. Which pair subtracts to be 5? Right, the 7 and 12. The 12 would have to be positive and the 7 negative. All right, so this time when you separate the middle term into two terms, both terms have to have an x squared. That's the only difference. So again, this could be done as long as the middle term is half the degree of the first term. So for instance, if it started at x to the 10th, the middle term would have to be x to the 5th. All right, so what can we factor from the first pair? Right, an x squared. From the second pair, we could factor a 12 out. 12 times 7 is 84. So x squared times x squared minus 7 plus 12 times x squared minus 7. They match in the parentheses, so that's perfect. If they don't match, we've made a mistake, or it can't be done. All right, so that gives us x squared minus 7 times x squared plus 12. It doesn't matter the order you write it. Now we're going to set each of them equal to 0. I don't know why I switched the order, but I did. Okay, so x squared plus 12 equals 0, and x squared minus 7 equals 0. Okay, let's do the x squared plus 12 equals 0 first. Okay, we're going to subtract 12 on both sides. And then we're going to use the square root property. So we're looking for real and complex solutions here. So we use the square root property. So we get rid of the squared on the left-hand side, and then we put the right-hand side underneath the square root and a plus and minus in front of the square root. So x equals plus and minus the square root of negative 12. You could use your handy-dandy calculator to simplify that. Make sure it's in complex mode. Whenever you have a negative in the square root, that just means you have to use the letter I to represent a complex number. And then you take the square root of 12. 12 is 2 times 2 times 3, so a 2 comes out, a 3 stays inside. And then don't forget the I. So plus and minus 2i square root 3. Or you could put the I after the square root 3, just make sure it's not underneath the radical. So you can write plus and minus 2 square root 3 I. And the I is not underneath the radical. It's got to be outside of it. All right, let's do the other one. Add 7 to both sides. Now use the square root property. And that's it. X equals plus and minus the square root of 7. So we have 4 answers here. So plus and minus 2i square root 3 and plus and minus square root 7. 4 answers. And that's because the degree of the polynomial from the very beginning was 4. That tells you that you could have 4 solutions. In the last problem, it was degree 2, and we only had 1 solution, but that's because we got an answer of x equals 3 twice. So you can have the same answer more than once. All right, here's another one very similar to the last one. Again, the middle term is half the degree of the first term. So multiply 2 times negative 12. That's negative 24. And then we have these choices. Let's see, 1 and 24, 2 and 12, 3 and 8, 4 and 6. It's a minus 12 or it's a minus 24, so which pair will subtract to be 5? Right, 3 and 8. And the signs, we want to get a positive 5, so it's got to be a positive 8. Positive 8 and negative 3. All right, separate your middle term into 2 terms. It doesn't matter the order. If you want to put the plus 8x squared first, you can. I personally just usually put it in order as I see it, negative 3 plus 8 as I've circled the pairs. All right, so for the first pair, what can you factor out of the first pair? An x squared. How about the second pair? Right, a 4. So factor out an x squared from the first pair, that gives you 2x squared minus 3. And 4 from the second pair, again, that gives you 2x squared minus 3. Now put it together. So x squared plus 4 times 2x squared minus 3. It's called the product rule. The zero product rule. Set them both equal to 0 and solve. All right, x squared plus 4 equals 0. Subtract 4 on both sides. Now use the square root property. Square root of negative 4. That means we have to use the I. And then square root of 4 is 2. So plus and minus 2i. We don't need the square root because there's nothing left in the square root. The one on the right, add the root to both sides. Then divide by 2. Now use the square root property. So plus and minus the square root of 3 halves. Can we leave it like that? No. We have to rationalize the denominator. We cannot leave a denominator with a radical. So you're going to multiply both top and bottom by whatever the denominator is, which is 2. So square root of 2. So multiply both numerator and denominator by square root 2. Then on top, that gives you square root of 6. And on the bottom, it gives you square root of 4, which is 2. So now we have our 4 answers. Plus and minus 2i and plus and minus square root of 6 all over 2. Yes, please don't forget the plus and minus, because if you leave out the minus, the plus and minus, then you're leaving half of the answers off the list. So if you do that, you can only get half credit, right? You don't want half credit. Okay, this next problem is something you may not have seen before. It has a square root in the problem, and you may have done problems where you isolated the square root, but we're going to do it different this time. We're going to use a substitution. Okay, so what we're using is a substitution to get rid of the radical. So that square root of x, we're going to let it be some other letter. We'll choose the letter u. You can use any letter you want, k, y, it doesn't matter. Sometimes we use the letters u and v when we're talking about substitutions. It's just kind of traditional. Okay, so u is equal to the square root of x. Now, we're going to have to get rid of that x also. So what we're going to do with this substitution, this u equals square root of x, we're going to square both sides. So square both sides. Just put both sides in parentheses and put a 2 outside the parentheses. Now on the left, what is u squared? It's just u squared. But on the right, square root of x squared, what is that equal to? Right, just x, because the square cancels out the square root. So we got u squared equals x. Well, we've done it. Now we have the information to replace any x that we have in our problem with the letter u. Okay, so let's go to it. It says in our equation x minus 12 square root x plus 32. So that first x, we want to replace it. What is x equal to? Well, looking at what we have on the right, x is equal to u squared. It says u squared equals x. That means x equals u squared. So x is going to get replaced by u squared. Square root of x, well, what is the square root of x equal to? Right, it's equal to u. So now we have u squared minus 12u plus 32 equals 0. Okay, we could factor this. Let's see, 32, 1 and 32, 2 and 16, 4 and 8. I think that's it, yeah. All right, which pair will, oh, it's a positive 32, so which pair will add to be 12? Yes, the 4 and 8. How about our signs? We want it to equal a negative 12? Both negative. Yeah, good job. So this will be u minus 4. I'm not doing the whole grouping here. I'm just putting the numbers in because it starts off with just a u squared. So u minus 4 times u minus 8. Set them both equal to 0. You could probably do that in your head. So we get u equals 4 and u equals 8. But we're not done. The problem didn't even have a u. So now what we got to do is we go back to what we have on the right, and remember that u is equal to the square root of x. So where you see a u, you need to replace it with square root of x. So square root of x equals 4. Now how do we solve that equation? Yes, we square both sides. So you square both sides. Square root of x squared is x, and 4 squared is 16, so we get x equals 16. Now do the same thing on the right. Replace u with square root of x. Square both sides. Square root of x squared is x, so x equals 64. So our two answers are 16 and 64. So as we go on in math, using substitutions is going to be an important topic. So this may have been like one of the first times you've seen using substitutions, but it'll happen often in the future. All right, let's do one more. So let's do the same substitution here. Start with square root of x and make that equal to u. So u equals the square root of x. Now square both sides. On the left, it's equal to just u squared, and on the right, it'll just be equal to x. So now, wherever you see a square root of x, you replace it with u. Wherever you see an x, you replace it with u squared. So now we have 2u squared minus 11u plus 15. Let's do our factoring. Multiply the first number and the last number this time. It's a positive 30. So which pair will add to equal 11? Right, the 5 and 6. Both will be negative. Separate the middle term into two terms. Factor a u from the first pair and a negative 3 from the second pair. It matches in the parentheses, so put it together. 2u minus 5 times u minus 3. Now we could use the zero product rule. So 2u minus 5 or u minus 3 equals 0. Solve both equations. Move the 5 over to the right, then divide by 2. So u equals 5 halves. And on the right, just move the 3 over, u equals 3. Are you done? Heck no, right? We got to replace the u with square root of x. So square root of x equals 5 halves. Now square both sides. So x equals 25 fourths. Do the same thing on the right. Square root of x equals 3, square both sides. And x equals 9. Those are our two answers. And we're all done. All right, so this lesson was just on a few different equations that were in quadratic form. Actually, the problems that were to the 4th degree with the 2nd degree in the middle, those could also be done with substitution. So you may want to go back and try to do a substitution on those problems. In that case, you will let u equal x squared. All right, I'll see you here for the next video. Have a good day.